As of SAP NetWeaver 2004, you can save data as shared objects in shared memory across different programs and even different user sessions. Accordingly, you can create applications in which users write data to this area. Other users can then read this data later. Shared memory is a memory area on an application server that the ABAP programs running on the same server can access. Before SAP introduced shared objects, ABAP statements had to use the export and import statements with the shared buffer and shared memory additions to access this memory area. Instances of classes were active exclusively in the internal session of an ABAP program. With the introduction of shared objects in SAP NetWeaver 2004, shared memory has been enhanced with shared objects memory, where the user can save shared objects. You can save shared objects in areas of shared memory. Note, instances of classes can be saved. It is not yet possible to save any data objects as shared objects. However, you can save data objects apart from reference variables as attributes of classes.
The figure explains how a shared object is being viewed by two user sessions simultaneously. Shared objects can be as follows. The write accesses should not be frequent because writing data to the shared objects area is performance intensive. Specifically, you want to optimize runtime, which would be lost if write access were more frequent.
An area is the template for area instances in shared memory. One area can generate several area instances, which differ by name. In addition, an area instance can have several versions which differ in their version IDs or version numbers. In the simplest case, without version management, an area instance consists of a single area instance version.
You define an area in transaction SHMA. This creates a global, final area class of the same name. This is a subclass of CL_SHM_area. In an ABAP program, you can access the area exclusively using methods of the generated area class. The figure also illustrates another class, which is the area root class. You can create any number of objects in an area instance, depending on your specific program. You access these objects uniformly through the instance of the area root class. Note, you limit yourselves to two classes in a specific example. In this lesson, you develop a simple catalog application as an example. You want to use shared objects to create a catalog of flight dates where the users can select any flight quickly.
The figure highlights the fact that any programs can access objects in the shared objects memory. In this case, two applications which run in different user sessions access objects in the same area.
You save shared objects in areas of shared memory. You use transaction SHMA to create and manage areas and their attributes.
After you choose one of the push buttons, create, change or display, the system displays the maintenance screen for areas. Important terms for creating an area are as follows: client-dependent area. Areas, and thus the objects within an area, do not have a client ID by default. You can, however, specify an area as client-dependent. In client-dependent areas, the methods of the area class for accessing an area instance refer to the active client by default. You can use the optional importing parameter client to access another client explicitly. Transactional area. An area instance version of a transactional area is not active immediately after you remove a change log with the detach_commit method. It is not active until the next database commit. This is particularly helpful in implementing shopping carts in the shared objects memory. To set up an area or access an existing area, you need a reference variable that you can type with a generated area class. This reference serves as a handle for accessing the area.
When you instantiate the area class, the system creates an instance of the area in shared memory. The program has a handle for this instance of the area. It performs all future operations using this handle.
Once you create the area instance, you can create the objects in the shared objects memory. To do so, use the area handle addition for the create object statement. This statement informs the system about the area instance where it should create the objects.
The figure illustrates how you can instantiate both objects from within the program. Alternatively, you can instantiate the root object from within the program. You can create the other objects in this area instance from the constructor of the root without assigning references in this case. To be able to address the objects that you create in the area instance, assign the root object to the root attribute of the area handle. To do so, use the set_root method of the area handle. As a consequence, any program of any application can access this area. To do so, the application merely has to fetch a reference to the area instance and can then immediately access the objects contained in that area instance. Read access of an area instance is not possible until the release of write lock. For the read access, use the detach_commit method, which inherits the area class from class CL_SHM_area.
Once an area instance has been set up, other users and applications can access it. The reading programs have to implement the following steps. The read program first needs a reference variable, that is, you type with the area class. This reference variable serves as a handle for the area instance access. The program obtains the handle for the area instance using method attach_for_read, which class CL_SHM_area provides. This sets a read lock that prevents the system to erase the area instance during the access. The objects in this area instance are now accessible by always using the area handle.
Once the read activity is complete, the application releases the read lock using the method detach of the area handle. The application automatically releases the read lock when the internal session is closed after a detach statement.
When you create an area, you can specify that the system allows several versions of an area instance. To determine what exactly these area instance versions mean, you need to examine an example. A normal state is when an area instance has been set up. Once the setup is complete using method detach_commit and the system sends a database commit, the area instance version is active. If the number of versions attribute of the area is set appropriately, additional versions of the area instance can exist in addition to the active version. When a new catalog is being set up, several temporary versions of the same area instance exist concurrently. As soon as an application sets a changelog for an area instance, a version being set up is created and exists in parallel to the active version. If you complete the setup of the new version during a read access of the currently active version, the version being set up becomes active. The previously active version is given the attribute outdated.
The read logs for the outdated version remain until the read operations are complete. In contrast, new read logs for the area instance are always set for the active version. Therefore, two different readers can produce two different read results in this case.
When you remove the last existing read log from outdated version, the outdated version expires. The garbage collector then deletes the expired version. You cannot set any read logs for versions that expire or use them to determine the number of versions. This is important if the system restricts the number of area instance versions.
New read logs are always set for the active version. There can only be one active version for each area instance. Depending on the maximum number of versions, several outdated versions for which read logs are still set can exist in parallel to the new version.